Hello, welcome to another session on circles. This time we are into taking the theorems on angles subtended by the arcs. Under that, the first one I take up, we write it here though. It says the angle subtended by an arc of a circle at the center is double the angle subtended by it on the remaining part of the circle. Now what it means is, suppose I draw, see, this figure can be drawn in three different types. If I take the arc, this one, okay, now how can the angle be drawn at the center and on the remaining part of the circle? It will, suppose the center is here, the angle at the center subtended by this arc will be this one, which I mark as center O, and this might be POQ. To make this an angle, I'll also join this two. This is the angle subtended at the center, and any angle subtended on the remaining part of the circle can be like this. I can also name this as R. On the other hand, this arc which I have drawn as minor in this first figure can also be drawn as a diameter of the circle, right? Because that's also become a chord. And one more in the case where I can take PQ as a major arc, as because here I am taking it as a minor arc, I can take it as a major arc and I draw the figure as like this. This then becomes your P and Q. This becomes the center, and the angle subtended at the center becomes like this, and the one on the remaining part as because I'm taking this as a major arc, the remaining part becomes the rest of it, so maybe somewhere here. And this is the center and the angle drawn, and the remaining part will be like this. For each of these three cases, we'll be trying to solve and prove how this angle at the center, this one here, this one here, and this one here, is double the angle drawn at remaining parts. So to start with, we can write the case 1, this one. This is where arc PQ is minor. This one is arc PQ is minor. If you observe this carefully, I also need to divide this and draw a line which is passing through the center and the point R. In this triangle POR, this point of intersection also we need to name. I name this as point of intersection, which might be M. This is the point of intersection. Look at the triangle POR. If I just highlight that, you would be able to observe which one I'm referring to, the external angle. Look at this one. This angle can be the exterior angle to the triangle POR. So I write that in triangle POR, as because I said angle POM is the exterior angle, it can be equated to angle POM. Here you can write, later on I will write that it's an exterior angle. It's equal to the sum of the two interior opposite angles. So it becomes the sum of these two, this one and this one. So we can write it as angle OPR, angle OPR plus angle ORP. Here I write in the bracket that this one is the exterior angle. As because this OR and OP are equal because they are the radii, so these two angles, angle OPR, angle ORP, they will be equal, angle opposite to equal side. So we can substitute one with the other and express angle POM as angle ORP plus angle ORP, thereby making angle POM equal to twice of angle ORP. And here in the bracket you can write angle ORP is equal to angle OPR. And why? Since OP is equal to OR. That's it. This is first part of it. Now on the other triangle, which is triangle QOR, will follow the same thing. Okay, the same whole thing will be followed. This one will be taken as the exterior angle, that is angle QOM. Will be equated to the sum of this angle and this angle, and these two are also equal, OR and OQ being the radii. So we can write here as similarly in triangle QOR, angle QOM will be equal to twice of angle ORQ. Now if we add these two equations, suppose this is our first equation and this being the second equation. Now adding these two equations will get, I'll write with some other color, this is POM plus angle QOM will be equal to twice of angle ORP plus twice of angle ORQ. Now if we take 2 common, and POM plus QOM becomes the whole of angle POQ. So this becomes whole of angle POQ. And 2 if taken common will be left with angle ORP with angle ORQ. Makes ORP and ORQ makes angle PRQ. So angle POQ becomes twice of angle PRQ. So the angle at the center, this one which is POQ, is now twice of the angle which is subtended on the remaining part of the circle. So we have proved this statement or the theorem on the first figure. The second option which we have taken now is PQ is a semicircle. The arc PQ, this one is a semicircle. Again we know that the same application will be doing. Yeah, we'll try to draw this line which passing through the center, and also will name this as the point of intersection being R, this point of intersection being M. Okay, look at the triangle POR. Here again the same we can apply. Angle POM is exterior angle and will be equal to the sum of 2 opposite interior, will be the same. You'll apply the same whole thing, whatever we have done here for this one can be applied even for these two. Here also you will get angle POM equal to twice of angle ORP with the same solution. You will also get angle QOM equal to twice of angle ORQ, and then when you add, you will see that the angle at the center, that is POQ, is again twice of this whole thing. Method remains same. Let's now move into the third case where PQ, this one we have taken as the major arc. We'll also be drawing the line which passes through this. This point we have been naming as R, and this point of intersection we have set to be M. Now again the same application, exterior angle is equal to the sum of two interior opposite angles. So look at the triangle POR. In angle POM, which is the exterior angle, here you can write this being the exterior angle, is equal to OPR this and ORP this one. So this is equal to OPR plus ORP. As we did in the first, this whole thing remains same except for the fact that the arc keeps on changing, thereby the figures also get changed. Again we know that OP is equal to OR, so these two angles are same. You can take the same writing and apply on the three figures which we have drawn. Here also you will get angle POM equals to twice of ORP. Same again, angle QOM will be twice of angle ORQ. Here the external angle becomes QOM, this one. You can again add these two equations, thereby getting this one. When you are saying that the angle, when you add POM and QOM, we mean this one, this angle, that's a reflex angle, because we have taken this at the major arc right now. Don't confuse it with the other side. We are not taking this one, we are taking this one of the angle which is POQ. Hope you can revise it by yourself by drawing the figures and try to apply the same solution for all three of them. Thank you.